What if you could interact with cells like fish in an aquarium? Build your own microaquarium to play with cells. Or do remote control experiments using a robotic biolab in the cloud. We are already doing this here at Stanford. We call this interactive biotechnology. There was a time when computers were these big clunky machines housed in buildings. Nowadays we carry them in our pocket and it makes it really fun interactive experience. And if you look at biology today, it's similarly very hard to access, and what we want is to bring it to people in the same interactive way. Today I'm going to tell you about 3 projects that we do. One, you can play with light-sensitive organisms. In the second, we show you how you can build these devices yourself. In the third one, we will show you how you can do experiments over the web in our lab via your phone.
There are freshwater microorganisms called euglena. They're responsive to light because they're photosynthetic. Whenever I draw something on the screen, the computer takes my finger input and draws the exact same line pattern on the projector, which creates this light projection pattern.
Biotic games are a fun way to motivate the students to learn about devices. This is an example of one of the things a student might build in the class. And ultimately, what it allows you to do is to control the intensity of the lights which the organism euglena will respond to. We're also working on developing a kit that people could buy for somewhat low cost.
So we already have cloud computing where you compute something at a remote location. Turns out in biology, a lot of the experimentation follows a very standard protocol. Some of the experiments, we can build robotics for this experiment that we can put in a remote location, and you as a user can send instruction that needs to be performed. This is basically a flatbed scanner. We ripped it apart, and then we use this as an imaging device. So we put petri dishes in this stencil. So the slime mold is placed on agar plates, and those plates are placed in this stencil here. And the job of this pipetter is to dispense liquid oatmeal solution on top of those physarum, or the slime mold.
What I hope is that these kind of interactive devices make us more comfortable, make us more informed, both in informal ways as well as using for formal education. And then of course you can also think of how we do experiments as scientists.
And one of the things that I really want to achieve is seeing this thing at large scale. So right now we can support like 18 people, but I want to see 1,000 people using such a thing.
It's always hard to predict the future. The best way is to invent it.